Thanks to Skillshare for supporting this episode of Journey to the Microcosmos. The first 1,000 people to click the link in the description can get a 1-month free trial of Skillshare's premium membership so you can start exploring your creativity today. We recently did an episode about nematodes, the phylum of worm that outnumbers just about every animal on this planet. Now, it's not the most striking of animals, but the nematode has had a few distinguished scientific decades thanks to its many uses in laboratories. So as far as worms go, the nematode seems to dominate much of our scientific understanding. But worms, despite their seemingly simple bodies, are a diverse bunch. Which is why we thought for today it might be fun to visit with a less famous worm. They're like one of those relatives that you don't really know very much about, but every time you see them, there's a new strange story to unpack. They are the aeolosomatids, a family of freshwater worms. The ones that you see here are invaders. They showed up uninvited in a blepharisma culture that James, our master of microscopes, has been taking care of for a long time. And while aeolosoma worms are, worms, they are in a different class of worm, because as we have seen before, there are in fact many ways to be a tube. Where nematodes are roundworms, aeolosoma are segmented, placing them in the annelid phylum along with earthworms and leeches. Aeolosoma are usually several millimeters in length, their bodies divided into more than 10 segments that you can see scrunching up and expanding as the worm wiggles its way through the microcosmos. And the aeolosoma are striking to look at. You can see their organs through their transparent bodies, and as it moves, bundles of long bristly hairs wave along the side of its body. Those hairs mark the aeolosoma as a specific type of annelid called a polychaete, or bristleworm. Some bristleworms are found in unusual places, like hydrothermal vents, but our aeolosoma come from a much more mundane home. They're usually found in bodies of fresh water where they like to crawl among the leaves and algae that settle at the bottom of the water. And inside their bodies are colorful gland cells, though no one is really sure what those cells exist for or why they have their particular colors. In some species, the cells are green, and others they're yellow, and sometimes, as with our worms, they're red. The final result is a worm that looks a little like it ran into a porcupine while also having caught chickenpox. While there are some aeolosoma species that reproduce sexually, most reproduce asexually, dividing to form a copy of itself. The aeolosoma creates its clone at its end, linking the old and new versions of itself like a chain. You can see the new aeolosoma here, looking like it's attached to the other's butt, because it's attached to the other's butt. And this chain can keep going as the aeolosoma keeps dividing, adding more worms that are connected together so that the final length of their combined bodies sometimes reaches around 10 millimeters total. That's 10 millimeters of clones combined to create one giant megaworm until eventually the chain breaks and they all go their separate ways. So when James found these worms invading his samples, you'd think maybe this would be an exciting find. Here is a culture full of bristled, polka-dotted, chain-forming clones. What could be more exciting? Well, as wonderful as they are to look at, these invasions are not ideal, because they are also essentially vacuum cleaners. Their mouths are lined with cilia that wave around and help the worms suction up bits of plant and animal debris. When they're in a pond, they like to crawl across leaves and algae for their meals, but when you find them in bottles of ciliate cultures you've been lovingly maintaining, that's when things get a bit dicier, because aeolosoma will eat just about anything, including each other. Indeed, in one very dramatic scene documented in 1901, scientists observing the species Aeolosoma tenebrarum described the way these chains of worms would twist up in each other, creating a writhing, tangled ball of worms that would stay stuck together for long periods of time. And when the scientists pulled these balls apart, they usually found at least one worm that had been partially eaten. I'm sure the etiquette around cannibalistic frenzies varies, but for most animals, getting eaten by another member of your species would seem, at the very least, a little rude. But when you're Aeolosoma, it's not that big of a deal. Honestly, it's not much more than an inconvenience, because if a part of it gets eaten, it can always regenerate. In one case, the scientists watching these balls of worms found that one worm had its head eaten, but in about 3 days, it was able to make a new one. It would probably have taken less time to regenerate other parts of their body. Heads seem to take the Aeolosoma a bit longer, perhaps because of all the complex parts that need to be rebuilt. And the Aeolosoma can regenerate even when it is cut into multiple segments. This superpower has made one species called Aeolosoma viridae particularly interesting to scientists. And it's not just that they can regenerate. After all, as incredible as this ability is, there are plenty of other animals that can regenerate as well. But scientists aren't just interested in how animals regenerate, they also want to know how those regenerative abilities change as the animal gets older. That's a difficult question to study because, as you might expect, self-healing animals have often pretty long lifespans. So it's a challenge to wait years or even decades to study how their ability to regenerate changes with the wear and tear of aging. Aeolosoma viridae, however, has a lifespan of only about 2 months, which means it goes from young to old on a manageable timescale for scientists cycling through experiments. And that makes it a useful organism to observe how that capacity to rebuild itself changes as the worm ages. But as useful as regeneration is for survival, it is not the only tool the worm relies on. After all, not all dangers can easily be patched up by rebuilding body parts. Sometimes the worm has to preempt dangerous conditions, and for that, it turns to the cyst. In nature, the worms will likely begin forming these cysts in autumn when the water gets cold and begins to fill with the remains of decomposing life. And as the temperatures continue to fall, the worms begin to slow down, crawling to areas full of delicious debris for them to stock up on, and eventually, the worms begin to secrete a mucus, creating a gooey shell that then hardens into a cyst. You can see the granules of red pigment swirling around as the worm moves inside. Some of that activity might be the peristaltic movement of its intestines, but it's also possible that the warmth of the microscope lamp is causing the worms to stir as well. And in their ponds, when warm weather comes, the worm will get ready to emerge from its encased hibernation, using its head to push at the hardened case of its cyst until it manages to poke a hole through from which it can escape. It can take a worm anywhere from 30 minutes to several hours to make its exit, and if there's a thick coating of bacteria on the cyst, it may even take the worms several days. And from there, well, it is a life of suction feeding and chain link clones and regenerating. Perhaps not normal to us, but what's normal anyway? Especially when you're a worm. Thank you for coming on this journey with us as we explore the unseen world that surrounds us. We would also like to say thank you again to Skillshare for supporting this video. Maybe you're sitting there thinking, I'm tired of watching all these YouTube videos. I want to try making some of my own. Well, that is one of the many things you can learn to do using Skillshare. There you will find the course Filmmaking for Content Creators, where host Aaron Palabiab teaches you how to be an efficient and well-prepared solo filmmaker, whether it's for your own content or for professional work. His course aims to both demystify the filmmaking process and empower you to shoot high-quality videos all on your own. Skillshare is an online learning community that can help you make 2022 a year of new learning, growth, and connection through creativity. With so much to explore and real-world projects to create, Skillshare empowers you to accomplish real growth. It's curated specifically for learning, meaning there are no ads to distract you, and they're always launching new premium classes so you can stay focused on leveling up your skills. And if you're one of the first 1,000 people to click on the link in the description, you can get a 1-month free trial of Skillshare's premium membership. There are a bunch of names on your screen right now, and those names are tied to people. And those people are individuals who each made an individual decision that they would like this content to exist on the internet. And if you feel like this content should exist on the internet, maybe you would like your name to be here, and that can happen if you become a Patreon patron at patreon.com/journeytomicro. If you want to see more from our master of microscopes, James Weiss, you can check out Jam and Germs on Instagram, and if you want to see more from us, there's always a subscribe button somewhere nearby.